Hello everyone, welcome back to my channel. Today we are going to talk about hydrocolloid, also known as aqueous elastomers impression materials. We know that in elastomers we have two variety, the hydrocolloids or aqueous elastomer, and then another one is non-aqueous elastomer, which we will discuss later on. The hydrocolloid or aqueous elastomer are named so because of their hydrophilic nature, because of their liking nature with water. We have two kind of aqueous elastomers. The first one is the agar, the another one is alginate. The packing for this particular agar impression material is like this, and the similar will go for this. We can always name them based on their name written on their paper. We can always identify them like that only, right? So what is the difference between agar and alginate? Agar being a impression material which set by physical nature, which set by the variation, the change in the temperature. On the other hand, alginate which set by chemical reaction. Since agar is set by change in temperature like impression compound, it is also reversible, so we can use it again and again. But contrary, alginate is set by chemical reaction, so it is not reversible, it is irreversible. So once you took the impression, you can't use the same material again, which is kind of good for it and can be, sometimes people do use impression compound as repeatedly, which lead to cross contamination. So with the thing is not replicate in alginate. When we talk about the composition for agar, if we look at it as a, like we want to learn about agar, right? So let's just say what we need for an agar. The very first thing we need is agar, basically agar, which is basically a seaweed. So we need seaweed, right? But what is wrong with seaweed is it's something like a clay. It's like more of a fluid. It is not usable at this point. It is not usable as impression. So we need strength in the fluid, right? So to give this strength, we use borax. What does borax do? It gives strength to the agar. So we can take the impression, we can pull out without tearing it off, right? So we need strength, and for strength we use borax. So we use agar, then we added borax to it to give strength to it. But what happens is borax have a disadvantage, which is it delay gypsum setting reaction. What is gypsum? Gypsum is something we use to pour the impression. We used to pour it and then we make cast out of it. But if setting reaction is delayed, then it's a disadvantage, right? To counteract this disadvantage, we use potassium. What is potassium? Potassium is something which is known as gypsum hardener. It increases the setting of gypsum. So it's basically counter the effect of borax. We use potassium sulfate. The similar potassium sulfate is used in various impression material. Its purpose is only and only to increase the setting of gypsum. It makes gypsum harder faster. And then since we need more strength to it, we use fillers. We always have fillers in, even if the composite or is the GIC or is the agar, everything have fillers. And trust me, all of the time, maximum of the time is just going to be diatomaceous earth and silica. So how you gonna write the composition? You first start with agar need agar, but agar is weak. We need borax to it because it is strength, but it delay the gypsum setting. So we add potassium sulfate to reduce the effect of borax, reduce the side effect of the borax. And we use fillers to increase the strength and increase the viscosity, so it can be moldable, right? So make it kind of like semi-solid. Then we add water. Why water? It's the principal constituent because it's a hydrophilic impression material, right? We need water because it's set by physical reaction. So when we add water, when we boil it and when we cool it down, the agar undergoes changes between sol and gel form. It's the water which help in changing the form, which actually help in taking the impression. We will deal with that later on, don't worry. Then thymol, similar function, it's bactericidal, right? We need something to minimize the effect of cross contamination, right? Then the plasticizers, it increase flow. What is plasticizers? Plasticizer is something like, for example, say this is one layer of borax, right? And this is another layer of borax. In between we have plasticizers. It's basically increase the flow of one layer of agar over the another layer of agar, right? Basically, like it's something like a lubricant, you can say. So plasticizers, wherever it is used, even if it's used in composites, it's the same mechanism. Even in composite or in polymers or in any impression material, its purpose is to increase the flow of the impression material, right? So nothing is, I told you that why we use water, that help in setting of the agar. How? What happen is, see, for what we do in impression with agar is, we have a tank, a big tank which contain three chambers. The first one is liquefaction unit, another one is the storage unit, and the last one is tempering unit, right? So what happen is, normally your agar is at normal temperature, right? What you do when we put it in liquefaction unit, the temperatures increases, correct? Its temperature increases and its state from sol to gel become. What is sol? Sol is basically, you can say that there is a liquid which contains powders. That is sol. Basically, something like you take a lot of water, you put some solid particle into it, like say sand. You put a sand into it. That's a sol form. What is gel form? Gel form is something which act like a say elastic solid, you can say. Like for example, you use mixed the flow, right? You do the kneading of the flow, right? What you do, you took the water, then you pour the flour into it, right? And in the state where the liquid contain the particles of the flour, that is sol form. Over the period, it get mixed and it certain form into a gel form, which is like an elastic solid, where you do the actual kneading of the flour, basically the wheat part, right? Actually do the actual kneading of the flour. So in that state, when it is shifting from one form to another, that is stosis, right? Stosis is basically between a lag between gelation form, when it's forming into a gelation, when it going into a form of kneading stage, when you can knead the flour, that is gelation. And liquefaction is when you just mix the flour into the water. So that state, difference between that stage is known as hysteresis, and its significance is in that stage only you can manipulate it. The same thing happen, like when you use the impression compound, it's a solid state, right? Then you put it into the very hot water, and over the period it get warm, it get heat up, and then it become something like a clay. That is kneading state, where you actually knead the impression compound and then you took the impression, and then over the period it set within the patient's mouth, right? So same thing happen here, just the opposite. Earlier it was just a liquid with powder into it, then it formed into a clay form, and the difference between that, in that time you manipulate it and you put into the patient mouth, you took the impression, and when it become the needed part, when it becomes set, you took it out, right? So first you put in liquefaction unit, where you heat it up, then there is storage, most of the time you store it here only, and then you do the tempering, which you keep it at this temperature so that it do not burn the mouth of the patient, right? So liquefaction is you change the state of it, then you maintain it in tempering state to lower the temperature sufficient enough that it do not burn the mouth of the patient. And here you can take the impression just after it. You just remove from the tempering tank, you take the impression, you have run 3 to 5 minutes, sometimes even up to 10 minutes, and then put it out, right? So there's one more thing I would like to tell you is that at high altitude, like in Colorado in US, their boiling point is higher for water. What does this mean? That in, like for example, in India, boiling point for water is 100 degrees Celsius, right? At 100 degree it will be in the boiling stage, but in Colorado, because there is high altitude, then boiling pressure will be, vapor pressure will be high. So in that state what would happen is your water will boil around 105 degrees Celsius or 110 degrees Celsius, right? So you have to heat up more to reduce the boiling point. You reduce the boiling point from 100 degree 10 to 100 degrees Celsius. We add propylene glycol to it in liquefaction tank. This propylene glycol had to reduce the boiling point of the water, and we can use it more efficiently. So we do not have to heat up even more of it, right? See, since we are taking press in a very hot temperature, we need an circulating water. We have special tray for the impression with agar. These special trays have a feature which is circulating water. And what is the purpose? To cool the agar. Correct? So temperature is just 18 to 21 degrees Celsius, and it gives you around the time lapse of 3 to 5 minutes. That much is enough to take the impression. Correct? What are the advantages of the agar? Agar being a very good impression material, have a very good dimensional accuracy and reproduction of the detail. It is so good, we use this feature to replicate the cast. Can you assume? We use an impression material to replicate the cast. So what does this mean is, we take the impression of the mouth, correct? We pour the cast. Now we want another cast from it, but the impression is wasted. We could not save the impression, and or sometimes what happen is in the lab the person has to replicate the cast to do the fabrication. We pour the cast in dental stone and they want the cast in die stone. So what will they do? They replicate the cast with agar. Agar gives the best replication of a cast or anything, right? It has the best dimensional accuracy. Then it is hydrophilic. That's a good point, because in a cavity we have a lot of saliva, so hydrophobic will make it very difficult to handle, right? Considering we have to deal with heating it up, then it has to be hydrophilic, right? After equipment, it is inexpensive, but before that its equipments are expensive, and after equipment they're saying that because it is reusable, right? Because it is reusable, and all you are doing is heating up water. You can heat up again and again and again. There's no costing for it. There's no need for custom tray. You can use the impression with stock tray, or you can use this special tray, you can say, but it is not customized to the patient. It is customized to the impression material, right? So you can use it over and over. There's no need of mixing, correct? It's something like similar to impression compound, right? Flavor is very pleasant, and I told you the best thing about this is cast duplication. It is not possible with any other impression material except with silicones we can use for cast duplication, but agar gives the best cast duplication. Disadvantages. What are the disadvantages of the agar? It acts as a semi-permeable membrane. Basically what does it mean? That the agar surface, it oozes out the water and it absorbs the water, right? So if it absorbs the water, it is known as imbibition, which is also shown by various fruits also, right? Dry fruits also, right? What is synergesis? Synergesis is when it oozes out the water, like something like this. When you took the impression, you put it on the table, left it there, then over the period it becomes wet over the surface. You feel like the moisture is all over the surface, but It's the water which is oozes out of the impression. What would happen if this? What would happen if there is synergy? Because of that, there is loss of water, loss of mass, and loss of volume from the impression. So basically, impression going to shrink. The same thing happen in alginate also. That's why we need to pour it immediately. We need to pour the impression immediately. If we left it over the period, water will ooze out from the agar, and which lead to shrinkage of the impression material. It have very poor tear strength. So if we are taking the impression in dentulous patient, it might we might tear the impression where we'll try to pull it out. It is very difficult to disinfect because we can't just immerse it into the glutathione which we use all of the time. How we disinfect the impression material? For all of them, it's glutaraldehyde except agar. Always remember, this is a very important question for NEET. We can use phenolic or bleach or iodoforms, basic household materials, but we need to gently wipe it instead of immersing into it. So there's certain techniques for agar impressions. The first one is laminate technique, in which what we do is we use agar as syringe material and alginate as stay material. So basically it's similar to how we took putty impression. What we do is we pour the alginate into the tray, we inject the agar onto the tooth, and then we use the alginate tray to take the impression. So basically when we took out the impression, we have both of them into the impression. The base of the impression will be made by alginate and the tooth part will be made by the agar. There is another method which is triple tray method, which basically mean that we have three trays: the upper impression tray, lower impression tray, and in between we have bite registration tray. So we are doing everything, all three of impression at one time. This is how agar impression will look like. Okay, and this is alginate impression, how it will look like, right? So now we are going to talk about alginate impression material. Same with agar, alginate also consists of its principal element, which is sodium alginate or potassium alginate, which consists of 50% of the alginate, right? Basically the main component. Then this main component need fillers to increase strength. As I told you, fillers always going to be same diatomaceous earth. You don't have to cross remember it. What does it do? It increases the strength and the stiffness. We need strength in the impression material. Why? We can't take impression just with the clay. It will be very soft. When we remove it, it will distort. When we remove it, it may tear off. If we do not have strength, while we try to pour it under the load of gypsum products, under the load of dental plaster or dental stone, it will break if it do not have enough strength. That's why we need a lot of fillers into the impression materials. We have reactors, calcium sulfate. What is a reactor? I told you it's set by chemical reaction. So there are two products, right? Basically there are two reactant, A plus B, which react into the product. So A being is potassium alginate and B being is calcium sulfate. So your potassium or sodium alginate react with calcium sulfate, which give calcium alginate, which will form final impression, correct? So it is very important. So you just have to remember 50% of sodium alginate, around 15% of calcium sulfate, 50-50, 30, 60% of diatomaceous earth, rest is 10%, which is retarder. We need retarder to modify the setting reaction of alginate. In fast set, it will be less. In slow setting impression, in slow setting alginate, it will be more. Then as usual, gypsum hardener. What does gypsum hardener do? It increase the hardness of the surface of the cast. Basically, the part which is contacting with the impression material, basically your alveolar ridge, basically your teeth, you want it strong. Otherwise, when you try to remove the impression material, when you try to remove the cast, the surface will be fractured and it won't be a very good impression. Then you won't be able to make the prosthesis. Correct? What would happen in reaction? I told you this powder in which we have sodium alginate, then we have calcium sulfate in the presence of water. When you mix it, what would happen? It form calcium alginate. Correct? And this calcium alginate is your final check. What does retarder do? See, we know that calcium react with alginate, right? But the sulfate need to be there, right? I told you alginate swap with sulfate, right? But what would happen is then when we add the sodium phosphate, this phosphate have high tendency for calcium, so it make reaction with calcium. Calcium is big. See, a phosphate is big boss compared to sulfate. We learned electron potentials in our 11th and 12th. It can follow the same concept. Phosphate has higher potential to bond with calcium compared to sulfate. So when we add sodium phosphate to it, the phosphate part from the sodium phosphate will bond with calcium to form calcium phosphate. Now we have formed calcium phosphate. The less amount of calcium will be available to make calcium alginate. Basically reduce the amount of available calcium for calcium alginate. There is another variant which is known as the dustless alginate. In this, polypropylene glycol is incorporated, which is very helpful in asthma. There is one thing I would like to tell you here is that in older books it is written as glycerin. But as of 2023, it is not the case. It is not the glycerin, but it's propylene glycol. Please correct this in your notes, also in your books. If you are reading standard books, it is propylene glycol now, right? And for the mixing, we have 16 gram, we know the standard term, 16 gram of powder, 38 ml of water. We mix them. How do we mix them? We take the water, then we add the powder to it. Why? Because we want complete wetting of the particle. What would happen if we put powder first, then we'll put water? Powder particle which are at the base of the ball, they won't be able to get wet, right? But if we took water first and we add the powder, then complete mixing of the particle will occur. That's what to remember for the theoretical part and to use in Viva, right? We use the figure of 8 motion in which we swipe and stopped motion use against the ball. We rub the spatula and the alginate. We kind of grind in between the spatula and the wall of the bowl. And the mixing time is 45 seconds to 1 minute. Thickness of alginate between the tray and the tissue when we took the impression, its thickness should be around 3 mm of the alginate, should not be more than that. It will be too thick and will fail to record the complete details. Correct? Then we know the setting time. Setting time is for normal it 3 to 4.5 minutes, and in fast settings it's 1.5 to 3 minutes. So around 5 minutes you can say. For normal in clinics you can use for 5 minutes, but for theoretical purpose you have to remember 3 to 4.5 minutes. Control. How do we control the setting time? How do we control setting? Best control by manufacturer, the amount of retarder accelerator they add to it. We know that water helps in setting of the reaction. So if we add more water, faster setting will occur, but we need to avoid it. We should avoid it because of that there will be heterogeneous mixture and it won't be an ideal impression. If you use cold water, it increase the setting time. So basically, it will set late. But if you use hot water, it will set faster. So that's why in summer it set very fast. Around 10-degree increase in temperature increase the setting time by 1 minute. Right? Increase the temperature by 10 degrees Celsius, your impression will set 1 minute faster. If you use gypsum, it will set faster. So that's why we should not mix the alginate in a bowl which has been used for mixing the gypsum. We should use separate bowl for mixing of alginate and separate bowl for mixing of the gypsum, because otherwise it will set faster. What are the disadvantages of the alginate? Same for agar, synersis, imbibition. Synersis is losing of the water. You can remember it as loss. Loss for S for synersis. Imbibition. Imbibition is input of water. Basically, water absorption, or you can say absorption. Ab for basin, right? High deformation. Why? Because of synersis. If there is ongoing synersis, it will lose a lot amount of water and high deformation will occur. Poor dimensional stability. Same reason, because of synersis and imbibition, it will absorb water or it will lose water. What happen is, what we used to do is, when we took the impression, we have been educated that we should put the alginate impression into the water, right? We can pour it next day, or we can pour it 2 hours later, 3 hours later, but we leave the impression in the water for longer period of time. It will cause imbibition and it will expand. If we put it in dry, if we let it dry, then synersis will occur, which will lead to shrinkage. But if we put in wet, in water, what would happen? Imbibition will occur, and because of that, it will expand. Its details recording is very poor. So for the impressions in FPDs, for the crown cuttings, especially for the zirconia, where we need the very good details, we do not use alginate. We use non-aqueous elastomers, and it is very difficult to disinfect, right? So this is all for alginate impression material, and we will discuss aqueous elastomers, non-aqueous elastomers in the next lecture. Thank you very much. We will meet again. Bye bye. Have a nice day.